we need to find the nearest palindrome to it. If it is 1 2 3, we need to have 1 2 1. If it is 1 2 9, we need to have 1 3 1 as the answer. Why? This is a palindrome which is the closest to 1 2 9. This is the palindrome which is closest to the number 123. So we need to find such numbers. Now it was easy at first glance, but there are a lot many corner cases to it. The corner cases can come such that if we just consider that what we need to do is go till the mid part of the string. If this whole is a string, just go till the mid part and then replicate whatever we have over here into this. It will give us the best possible answer. But it was not the case, because we can see that if 129, what we would have done, we would have just simply done 1 2 would be the half, and then we would have converted into 1 to 1, which will give me 8 as the difference, which is not the closest. Definitely the closest would definitely be 1 2 9s would be 131. Now we can also say that okay, this is a corner case, right? What we can do over here, we can just consider that 1 2, I will also consider 1 3 and 1 1 as my possible solutions, and then try to replicate the left half. After doing that, we will find that 131 and 121 are also the contenders for it, along with 111 are the contenders, 121, 131 and 111. All three are contenders for 129. The closest would definitely be 131, and 131 would be the answer. Again, after doing some tries, we will find that 99 or 101, if these are the values, then what would happen? If 99 was the answer and we would consider only these cases, then what we would have done? We would have considered that 9 and 9, this is already a palindrome, but we need to consider some number which is not a palindrome. So that is the question. So 0 we would have given as the answer, but 0 is not the correct answer. We should choose anything which is not itself. If it is not itself, right, smaller one, closest is that only, but this point is the main thing, not including itself, which makes one more corner case, that for 99 we should know that 101 was the answer and 2 as the difference, right? And for 101 we should know that 99 was the answer, again with 2 as the difference, right? So how can we do that? If it was a even or odd, we don't consider any, like, it does not matter. If it was just this, right, with a length 2, we'll just consider 100 and then we'll consider a plus 1. And then if it was like whatever length was there, we will consider 10 to the power length minus 1, which is like 10 minus 1, because for 99, that same number, I do not know if it was 99, right? It could have been 11 also. If it was 11, I need to be able to make sure that 9 is also contender. To make 9 as a contender, what can we do is 10 to the power of length minus 1 I will do, and then minus 1, which will be 10 to the power of 2 minus 1 minus 1, which is like 10 to the power 1 minus 1, which is like 9, and hence 9 also is my contender. So what are all the contenders for 99? For, if suppose it was 101 or 99, for any number we will have such 5 contenders. To bring all the 5 contenders, we'll take order of n time. So it is like 5 into n time would be the time complexity. Space complexity would be again order of n only, because we are storing those, 5n only, because again we are storing those only 5 contenders to it. The main things to note is what we will be using to solve it. Let us look at it. How do we solve it in the code? So in the code, we take the length, we take one more variable, is even, to determine if it was a even length variable or an odd length variable. So even length variable will have 1 2 3 as my first half, but an odd length variable would only have 1 2 as my variable, right, without the this part, middle one, which is common to both parts. So for that, to account for that, we'll take is even. Now it is just about manipulating stuff. And how do we get these 5 contenders into picture? We will take a contenders array, and then over here I am taking that if it is a length is odd length, then what I'm doing is I'm considering length by 2 as my half length. Why I'm doing that? So what will be the length of this one then? In that case, considering 1 2 3 4 5 as my example, this will have the length equal to 5, right? Then is even would be false. Then half length would be how much? Which is equal to 5 by 2, which is equal to 2. Half length is 2. Now what do we consider? We consider the first half. I need to make the first half. First half I need to make it this much. Now from the substring one, I know that the substring sub dot, like string dot sub str, this first element is from where we need to start, and this is how much count we need to take after starting from there. So if we consider this, we need that this should be half length plus 1, because what we need to consider over here is I equal to 0 should be the start. So 0 comma hl plus 1, because hl is 2 but we need one more for that, right? The same is the case for even numbers also. So 1 2 3 4, if we consider, length would have been 4, it would have been true, and hence we would have considered 4 by 2, which is equal to 2 minus 1, which is equal to 1. Over here also again we need till 2, like we consider 2 elements after starting from this index, so we are doing that plus 1 to account for that. We get the first half, and then stol, like stoi, this is a function which converts a substring or else a string to a long. That is the main part. And then we push all the 5 contenders into it. These 2 contenders we have discussed. It is 10 to the power of length minus 1 y, it was discussed before. 10 to the power of length plus 1 is considered. Now this one and this one are the 3 variables that we need to again put as contenders. These are like for 1 to 3 or 1 to 9, the first one would become 1 to 1, the second one would become 1 3 1, the third one would become 1 1 1. So these 3 contenders would be put in. The fourth line would become 99 as the contender, and the fifth line would become 1001 as the contender. So out of these both, we will know that 129 is the closest to 31, and we'll get the answer as 31. In this array we are doing nothing, but we are just, this part is mainly important over here. What we are doing is we are saying that if that n1 is already equal to the contender, we don't consider it, because if it was 99 and we are considering 99 as the contender also, if the n was only this much, we cannot consider n contender also as 99. So these both shouldn't be equal in 10. We have to count for that case. Other than that, this half to palindrome helper function we need to discuss once. How do we get the complete palindrome from this half length? Half length was 1 2 3. Now how do I get 2 1 over here? So if it was odd, what we will do? We will do 1 2 3 by 10, which will give me 1 2. Now we know that let us have the half length, the result as 1 2 3. Now using this first half, we need to calculate 1 2 3 2 1. Now we will just get this number, the last digit, and append it over here. Then we'll get this digit and append it over here. So we are just doing modulo tens operations. From back we will be getting each and every number in the while loop till we have a first half, right? So what we are doing is we will be getting from the back of that from 1 2 3. First we eliminated 1 2 3 due to this step, then we got 2 and we added it into the result, then we got 1 and then added it into the result. What was the result? Was 3. What we added? 2. Again we into 10, which gives me this, and then we added 1, which becomes 1. So what did we get? We got 1 2 3 2 1 as our result, which we push back into the contender list. So yeah, that was it. It was mainly focused on the edge cases, plus in the interview we can miss these edge cases, plus because this was also long, can handle this part, right? Edge cases, as well as how well we can efficiently we can make the other half. Like we needed to figure out that we needed the last digit only and append it to the result, and then this digit into the result. We didn't need any other stack or queue or anything to do it in the last in first out order, because the original order itself was giving us that value. So we can just do this, plus how to compute it using contenders. So this is the basic essence.